This is about AI, which is buzzword right now and very, very hot in the technology and skill in the market right now. So what is AI? It is like how human thinks using its brain. It's something like the programs or the AI things for computer. Like for example, if we have to find a difference between a cat and a dog, uh, how human brain does it. It just find the similarity and find a pattern. How so many that by looking at so many cats, we find the characteristics and then relate to that. And then whenever we see a dog or a cat, we can find a difference. Similarly, artificial intelligence or the machine learning, it finds a pattern and then try to solve the complex problem or give us the answer. Um, Sometimes AI is do things much faster and much more accurately, and sometimes even better, like what human can do it. It solves the complex problems much more efficiently and tirelessly. So there are so many benefits using the AI. Today, we are going to discuss machine learning and deep learning, OpenAI, ChatGPT, generative AI. I'm not sure how much time we will have, but also the vector databases. This is kind of the new way of storing information, how LLMs, which is the large language model, uses it. And then finally, if time permits, or in the subsequent sessions, we will discuss the reinforcement learning from human feedback. It's something like when we ask a question to ChatGPT, I'm sure like most of us has used it so far, the ChatGPT, which is an application which uses OpenAI language model. Sometime ChatGPT gives us a response or the reply to our question. Sometime it is correct, sometime it is not, sometime it's not even appropriate. So that's what human look at those responses. Like ChatGPT gives two responses for the same question. Human will identify that which question is correct and which one is not, and that's feedback human gives back to the language model, and it reinforces its learning to make it better. So that next time it gives the answer A compared to rather than giving the answer B, because that's the feedback it got it from the human. And that's why it is a very, very important concept in OpenAI or the any LLM. It is called the reinforcement learning from human feedback. I have a couple of slides and the demo. So how I break it down, I'm thinking of giving like the small introduction to each technology, and also I have a demo how hands-on you can perform those operations, or how we can use those tools to make it work. And then not just like the theoretical point of view, but also in if we really wanted to develop any application. Okay, so how does a machine learns? This is a very simplistic diagram where the data which we collect for any problem, that is divided into two parts. One is the training data and the other one is the test data. So say, for example, we have a data which contains, say, for example, 500,000 rows. So what we will do, mostly like that, it is a 70-30. 70% we give it, 70% data we give it to machine to learn it, and then 30% data which we kept it separate to test it, whether the prediction done by the machine learning is correct or not. So it goes through, let me get this laser pointer. Okay, so first we have a training data. That training data goes through the algorithms, and then using that algorithm, it learn it, and then we get a trained model, and that trained model we test it on the data which we kept it separate as a test data, and then that's how we evaluate whether the prediction is correct or not. So this is like just the process of going through learning, and then it does it again and again and makes lots of connections, which we call it neurons, like similar to the human brain, which has billions of neurons, and each neuron has a task to make connections to other neurons and pass on the information. Machine learning and deep learning does the same way, but we will go through that. So this is a simple example. Like, for example, we have a formula to convert Celsius to Fahrenheit. The formula is F equal to C multiplied by 1.8 plus 32, which we know that this is a formula. But what if we don't have formula, or think of that the machine does not have that formula? How does it predict if we give a centigrade value? So how machine learns it, as I mentioned before, that it makes connections, or it try to find a pattern, and then that once it finds create hundreds of patterns, it will start predicting, or the data start making sense to it, and then it will start predicting the right value. May not be 100% correct, but close to the right value. And as it get more and more data, it get trained and then gives the close to 100% right value. So for example, if we have input as Celsius as 0, then the Fahrenheit would be 32. If it is 8, then 44, 46.4 and 15 and 59 and 22 and 71.6. If we give this data, machine start to make pattern that if it is 0, then it is 32, then if it is 8, then it is 46.4. It is similar to like, I have just drawn it here. Like if I have number as 1, and then if I say the 1 correspond to A, 2 correspond to B, 3 to C, D to 4 to D, then what would be the value of 5? Of course, we know that its value is E, but how do we know? How does our brain know that if it is seeing this pattern up to here, what would be the corresponding value or the corresponding character or alphabet for 5? Because we know that each time we are just increasing by 1 here. Adding 1 to 1 is 2, 2 to adding 1 to 2, it will be 3. And then similarly, we are progressing by 1. So next number would be E. So the similar way artificial intelligence or machine learning try to learn or create that pattern, and then it start predicting that if it is 5, then it will be E. Sometimes what happens instead of E, if it say D for 5, then it is actually just little bit behind E. Or if it predicts F, then it is little bit ahead of it. So that's how that is what we call it, like the tuning, or that is called loss in machine learning language. That if it is behind, then we need to tune the parameter so that it will progress little bit forward. If it is going forward, which is not the right value, then it has to go back a little bit. And that's how we control the loss. But we'll see it in example there. So this Google has given us the utilities for that. This is called the TensorFlow. TensorFlow is a Google ecosystem of tools and libraries to build and deploy machine learning models. And they have also tools called Keras, which is the high-level neural network library, which enables the experimentation and deep learning models to run through. We will use it in our demo here. So I'll just show you a demo here. I'm importing TensorFlow here, and then NumPy from the Python libraries, and then Matplotlib just for the plotting. And here I have given 2 arrays. One with the centigrade, so -14, -10, 0, 8, whatever here, and then the corresponding Fahrenheit values. That's it. This is my data right now. And then we will see how does it learn it, how the machine learns it basically, and then start predicting the right value for the number or the Celsius which I'm giving it to it, but it hasn't seen it before. Then how does it predict that what would be the corresponding value? So what I do here, first of all, I create it out of this TensorFlow and Keras. I create a sequential model, and then I just give that one unit as 1 and input shape is 1. So when I say 1 means because this is a very simple problem. We know like just like need to create a pattern, which is a simple straightforward problem. That's why I have just 1 neurons. So the 1 neuron, that's why I'm saying here units equal to 1. This specifies the number of neurons in a layer, and layer is something like how complex the problem is. Because my problem is pretty straightforward, that's why I'm using just a single layer, and that's why it is here single layer, single neuron, and then it start to learn and then start predicting the value. But if my problem is quite complex, I need to have multi neurons, maybe hundreds of neurons created, and then also the multiple layers depend upon how complex it is. Say, for example, if I have to identify a car, if it is a Honda, say, for example, Honda CRV, then then machine has to just look at the car and then tell me that what kind of car it is. For that, it has to go through many layers because it has to identify the headlight, it has to identify the shape and maybe some logos or like doors. It has to identify so many small pieces, and then it will predict what kind of car it is using the deep learning. But for that, we need many neurons and many layers. But for my simple problem, I just need 1 layer and 1 neurons here. And then I just created I compile this particular model, and then I'm using the mean square error, which is it is like take the error, square of it, and take a mean, and then take a square root of it. So it is one of the way we can calculate the losses here. And I'm using optimizer Adam here. Adam is Adam is just a way to adjust the losses, whether it is going up or going down. No need to go into like too much detail on that here, but that's how I'm fitting the model or training a model where I'm giving the C as a Celsius, Fahrenheit as F, and epoch is 500, means it has to make 500 times it has to run the algorithm and try to make connections here. And I'm giving here verbose is equal to true so that I can see how does the model look like. So let me just quickly run it here. And I see how fast it is right now. I mean, so far I have just defined it, and here I'm building the model or training it. When I train it, you can see that this is the epochs. It just keep on going like the epoch is changing it. And then as it this will run for 500 times. And each time it is taking the mean square error. And then if you see that error is going down, if I start with initially like it was 123, it's 162, but it's going down drastically. Like now it is like 20. You see that here, this is 17. It came to 17, like quite low here. So if I plot it, if I plot this error and the loss magnitude, then as the epochs are going forward, like from 100 to 200 to 300 to 500, as it is going, the number of epochs or retries are increasing. It's decreasing the errors. So you see that the loss magnitude, which is going down, and then it is not 0, but close to 0 actually. So that means like my prediction would be much more accurate moving forward. So if I just give like say if I gave 100 and say 95, if I give 95 and ask it to predict it. Okay, 95. So if I ask it to predict it, it says 202. So 95 is too high actually. This is a Celsius. Maybe I've just need to 35. So this is 92 Fahrenheit, degree Fahrenheit. So that's how it like quickly it predicted. And then if I do it by hand, if I do 95 with this formula, then it gives me. Oh, sorry, not 95. It should be 35. 35. So it gives me 95. So actually what it predicted was 92.39, and it's predicting actual value is 95, which is off a little bit. But that's all because my data is very limited. It has just like the 6 or 3, 6, 7, 7 entries here. But in real life, we will have hundreds of rows or hundreds of sample data given to the machine learning to learn it. And number two, my layer was only one, my neuron was only one, and my epochs was 500. So if I increase all this, then my prediction would be much more accurate. And that's why it was a little bit off here. So there are some of the algorithms in machine learning. I just name it here: neural network, random forest, decision tree, and then nearest neighbor. Nearest neighbor is something like it finds the value. Like for example, this circled X, and it could have the potential matches. So these are all its neighbor, but the neighbor, it find the distance, which is the Euclidean distance. It's whichever is the closest distant neighbor using the Euclidean distance algorithm or the formula. That's how it finds it. This is called the nearest neighbor. So these are the ML algorithms, some of them, but there are others, hundreds of algorithms in the market. So how does machine learns it? There are three different types of way machine can learn, or not. There could be many more, but these are the most common ones. One is called the supervised learning. Supervised learning is something where we are supervising the data. Like for example, this diagram here, you see that we have the labeled data that this is tomato, bell pepper, and we have carrots here. And then we have the labels defined here that if this is the figure or the image, that is called carrot. And that's what we feed it into the machine learning model. And also we feed the labeled data. So we have already labeled it at what is called what. And that's how we learn it. Like we have already labeled that what is centigrade, what is Fahrenheit. Similar to that, we can label it and then we give it to the machine to learn it. And that's what it predicted. And then you saw that we have a test data, like we did our testing for 30 centigrade as 35 degrees Celsius. So similarly, we give the test data and then see what is prediction. And if it matches the prediction, means we are all good. But if it is not, then we need to tune the parameter. But the thing is here that we have already labeled that data, and then we are doing this learning in a supervised environment. And that's why it is called supervised learning. The second diagram you see here, which is the unsupervised learning, when we have no labeled data. And that's what it goes to first interpretation. Machine learns it and identify like which one is what. It goes to the algorithms, process it, and then categorize it. That this bell peppers are same, how this is eggplant or onions. But still the problem is it doesn't know which one is the red bell pepper, which one is the green red pepper, bell pepper. So this is the issue with the unsupervised learning, but we have ways to handle it. But broadly, that's why it is called the unsupervised learning here. And then the last one is the reinforcement learning, where it's the same as human, like baby. If a baby is sitting here and then if a baby is hungry, then it has to crawl. It has to take some action to go to reach to feeder, and then once he or she drinks milk, he get rewarded. And then once it get rewarded, then it's basically learned. Like if I have to go, if I'm hungry, I need to do this, follow these steps to get the milk bottle there. So this is the reinforcement learning, where it train itself more and more. And over initially, like it's any machine starts as a dumb machine, but as it learn and then correct itself, it becomes smarter and smarter over the period of time. That is why it is called the reinforcement learning. So these are all like the broadly categorization. I can provide like the examples, the real life examples, or maybe the working demo for each one of them. But this is the high level different types of machine learnings. And then we have the deep learning, where it is you see that here diagram, which is the deep learning goes all the way at the bottom, and then then the machine learning, and then artificial intelligence, and now we have the generative AI, and then now we have the critic GPT, and so the things are moving very, very fast. 4 years ago, when I started learning deep learning and machine learning, now most of the things no need to do that, because like those abstract layer are provided by the GPT or the OpenAI or the Hugging Face, different models are already doing it. So the technology is evolving really, really fast. So this is deep learning, where we have the inputs and then the hidden layers. These are also neurons, but which makes a connection. But these are the hidden layers in between the input and output. This is like just a high level how the deep learning works. And this is more like the little bit detail, like where we have the input nodes, we give the inputs, and then it makes connection to the different neurons here, and then it makes more connections and more connections. There can be hundreds of hidden layers in between the input node and output node, and that's what it generates the final output there. But this is still the high level things, which is, and then most of the neural networks are sequential. So this is just high level, and there are some neural networks, different types of layers. I just go through it quickly. That there are like the layers. This is called the convolutional layers, where each neuron is connected only to the neurons of its neighbor from the previous layer. Like for example, if you see that this one is connected to these two, this one is connected to these three, this one is connected to these three, and then like for example, this one is connected to the previous nearest neighbor. It's not connecting to this one. It's not connecting to this one, this neurons. It's just connected to the previous nearest neighbor neurons there. And that's why it is more sequential, and that's why it is more time consuming. This is RNN, which is called the recurring neural network, where the input is given and then output will be there. Each step is called the time step, and then in the next node or the time step, we have the input and also the output of the previous time step. So it's kind of like the feeding itself, and that's why this diagram shows here that we have input, output, and output is also feedback to the input again, along with the input, so that it can find the right value at the end. And so the latest one given by in 2017, a researcher of Google, they gave us something called attention is all you need. If you Google it, you will find this is the research paper published by Google in 2017, which is used most of the LLMs and the other machine learning models right now using it. This is called the attention is all you need. You can Google it. This one, which is giving us the basically brought the revolution in the NLPs, the natural language processings, and then it gives us the transformer architecture, which is not like the RNN and CNN convolution neural network. This follow the feed forward neural network, where each node and each neuron is connected to all the neurons here. You see that this is all connected to all the neurons, and then it goes to the next one. And then each time it produces, it gives input to the next one, and also tells it that how important how important information it is passing it on to the next one, whether you should consider it or not consider it. And that's how it's keep on doing it. And then finally we will have the output, which is the combination of output of each and every neuron's learning, and it passes it on to the next one and tells it yay or nay kind of things. You consider my output or not consider. It is not significant, or it is significant. So that's how it just keep on passing. What I can share a little bit. So this is the OpenAI things. Like we have the way we store, or we have been dealing with, is data which we store in relational database. But when it comes to the LLMs or the machine learning, or like now the OpenAI things, they store in a numerical representation of that data. So that's called vector. and then vectors are stored in the that's called, sorry, not vector, that's called embeddings, and that embeddings are stored in the vector databases here. So we'll go through that next time. Like this is the vector database for represent numerical representation of each and every word. I'll go through that in the future slides. And then how does the Google search Google searches the image, perform the image searches, and these are the vectors. I have demos for each and every one actually. And then this is called the RAG, which is the retrieval augmented generation. I have demo for that as well. And then the LangChain, what is that? The LangChain, what is OpenAI? What are the alternative of that? Hugging Face is one of the open source LLM providers. And then we have different kind of chains. How does it work it? And then agents, which the LLM uses tools for making action and going to the environments. One more just quickly here. Yes, when OpenAI provides, why do we need to go to different data sources here? The problem with the open sources or the ChatGPT is that it provides information only up to, I think, July 2021. So if you ask a question which happened in 2023 or 2024, it doesn't know. That's why we need to go to different data sources to get that data. Maybe it is Wikipedia, Google, or your own company databases. So that information it has to get, and then LangChain is the open source framework which build them together and make our life easy. It does so many things. So LangChain itself is a something new. It just introduced in 2022, and just after 2 years, it gained huge popularity in the LLM market right now. So I'll just discuss the different agent. How do you connect to your own data? And then this is the reinforcement learning things. How does it work? And then demo for that as well. So that's pretty much it for now. I mean,